Right now we're going to do our summary of science for the second semester. In Unit 8 we learned about gravity, and gravity is the fact that every object pulls on every other object. The sun and every planet in our solar system exert pulling forces on each other, and this is what keeps them orbiting around the sun. Alright, we're going to talk about orbits in a minute. Even tiny objects have gravity, but gravity depends on mass. And mass is the amount of matter in an object, so the more mass two objects have, the greater the force of gravity between them. So, even like this picture shows, even a golf ball and a tennis ball and a volleyball have gravity, but it's so tiny because their mass is so tiny. Alright, the sun is the most massive object in our solar system, so it has the most gravity. And it keeps the planets and other objects in the solar system orbiting around it. Alright. Distance also affects gravity. So the further apart objects are, the force of gravity between them decreases. Alright, so the sun has much more gravity than Earth because it's so much more massive than Earth. But it's 93 million miles away. And that's why its stronger gravity doesn't pull us off the Earth. Alright, Earth is the largest object close to us, so Earth gravity pulls us toward it. And the sun's gravity is much, much greater, but it's so far away that it doesn't pull us off. Right? So how does an orbit work? So think about this a minute. Here's the moon, and it orbits around the Earth. And an orbit is a balance between the pull of gravity and the forward motion. Okay? If the forward motion of the moon stopped, if it quit moving, the pull of gravity from Earth would cause it to crash into the Earth. If for some reason the pull of gravity was removed from the Earth, then the moon would carry on in a straight line. It would no longer orbit. So that's how an orbit works. It's a balance between forward motion and gravity. Alright. A long time ago, people used to believe that the Earth was the center of the solar system and everything else revolved around it, because after all, if you go and look at the sky, that's what you see happening. The stars and the planets and the sun seem to rotate around us. That's called a geocentric model of the solar system. However, as we observed stars and planets through telescopes, it was realized that the sun is at the center of the solar system. And this is called the heliocentric model of the solar system. So for exploring space, of course, we started with telescopes, but in the last century, in the 20th century, people began exploring space with rockets. And we actually had a space race between the United States and the Soviet Union to be the first to explore space with spacecraft. The Soviet Union started out strong. They were the first to launch people and satellites into space, but the United States caught up. After President Kennedy's speech, the United States was the first to land on the moon. Okay, and we're still exploring space today. We retired the space shuttle program, but we still have the International Space Station, where scientists go into orbit, and they up to 6 astronauts can live and work for months, and it's shared among many countries. We also send unmanned space exploration probes and robotic spacecraft to explore places that are too far to humans to explore. Like Mars, we have little robotic rovers running around on Mars, studying Mars for us. And we've actually recently had a space probe that flew all the way by Pluto and took pictures of Pluto for the first time and provided lots of information about Pluto. And humans don't even have to go. In the future, NASA has hired companies to build spacecraft to launch astronauts for us, and that's going to be coming up in the next few years. And NASA is also building a new spacecraft called Orion, and it'll be launched on this Space Launch System rocket. And we can use it to explore places a little further away from Earth, like maybe the moon again, maybe some asteroids, maybe even Mars. So it is hoped that in the future we'll be able to return to the moon, land on an asteroid, and maybe send humans to Mars. Unit 9, we learned about the rock cycle and layers of the Earth. There's 3 types of rock. there's sedimentary, metamorphic, and igneous rock. And they all are formed into each other through the rock cycle. So here's how we form sedimentary rock. We have to remember Wedkosi. We eat Doritos, corn, and cereal. What does that mean? Okay. The W stands for weathering, which is the breaking up of rocks. Erosion is the movement of sediments. Deposition is dumping or depositing sediment. Compaction is pushing down of sediment due to weight and pressure of water and layers on the top. And then cementation is the gluing of sediments together because of pressure. And that's how we form sedimentary rock. Forming metamorphic rock, well, metamorphic rock is formed with great heat and pressure. It's not enough heat to melt the rock, but it's enough to change it, kind of like cooking it. And it usually happens near a volcano or somewhere where there's great heat and pressure. So if you look at this picture of volcano, obviously where the magma's coming out, that would be igneous rock. But over here where the rock around it gets heated, that would form metamorphic rock. All right. You can also form metamorphic rock at a colliding plate boundary. Friction of these two plates colliding produces heat, and the collision produces pressure, and that forms mountains and metamorphic rock. Alright, so how do you form igneous rock? Well, igneous rock forms when the crust melts into magma and then the magma cools. That usually happens where tectonic plates get pushed down or subducted into the asthenosphere. So when this part of the tectonic plate gets pushed down, it gets pushed into the asthenosphere, the rock melts, it forms magma, the magma rises up to the surface, and that's igneous rock. The earth is divided into many layers. Obviously on the top is the crust, it's the thinnest layer. The lithosphere is the layer underneath that. It's also rocky, but so together the crust and the upper part of this mantle forms the lithosphere. Then there's the asthenosphere. That's the part that's solid with plasticity, which means it's a solid, but it kind of moves around and lets the layers of the earth on top of it move. The mantle, that's the thickest layer. The outer core is actually liquid, and then the inner core, even though it's hotter than the outer core, is solid because of all the pressure. So in Unit 10, we learned about tectonic plates. Okay, so Earth's lithosphere is broken up into pieces known as tectonic plates. All right, and this is a picture of all the different tectonic plates on Earth. Most of Earth's tectonic plates include some continental crust, which is land, and some oceanic crust, which is ocean floor. Oceanic crust is more dense, and continental crust is less dense. And most of the tectonic plates are named for where they are located, which is why you have a North American plate, or a Pacific plate, or a South American plate. Okay, remember we just talked about that the asthenosphere, or the top part of the mantle, has plasticity. It's a squishy solid that behaves like a thick liquid. Well, the tectonic plates float on top of the asthenosphere. And then heat from Earth's core causes convection currents, kind of like a lava lamp, to move the material in the mantle. So it moves around. And those convection currents in the mantle cause Earth tectonic plates to move very slowly. So they're moving very slowly, a little bit like inches per year. You know, maybe even only 1 inch per year. And that's why our tectonic plates move. Alright, there's 3 types of tectonic plate boundaries. You learned about these when we did the graham cracker lab. There's convergent boundaries, divergent boundaries, and transform boundaries. Okay, convergent boundaries, the 2 plates move toward each other and collide. Convergent collide, okay? Remember, we did the hand motions where they're coming together. Alright. There's 2 types of convergent boundaries. When continental plates collide, the crust gets pushed up and mountains form, like this graham cracker right here. When When an oceanic plate and a continental plate collide, the oceanic plate subducts under the continental plate. The oceanic plate then melts to form magma. This causes volcanoes to form, and we modeled this with these graham crackers right here. And this is a picture of another convergent boundary with subduction, because this part of the crust is getting subducted under this other part. There's divergent boundaries where two tectonic plates separate. This is where new crust is formed because magma rises up when the plates separate and it forms new crust. And this happens at mid-ocean ridges under the ocean mostly. And where it does happen on land in a few places, it's called a rift valley. At transform boundaries, the boundaries slide past each other. Okay, friction between the two plates at transform boundaries causes earthquakes. And here's a picture of when we did the graham cracker at a transform boundary. These two plates are sliding past each other. It's another picture of it and a model of it. California is known for its transform boundary called the San Andreas Fault. So that's why they have lots of earthquakes in California, because these two plates are sliding past each other. And there's a few places on Earth, like Hawaii, that are hot spots where there's just a hole in the crust and it allows magma to rise and forming volcanoes. Alright. In Unit 11, we learned how to classify organisms and cells. We learned that prokaryotic cells have no nucleus, and eukaryotic cells do have a nucleus. That's a major difference in how we classify organisms, whether they're prokaryotic or eukaryotic. We also learned that some organisms are unicellular, they only have one cell, while other organisms are multicellular, they have many cells. Alright. We also use how the organism gets energy to classify. If it's autotrophic, it makes its own food, like plants, using photosynthesis. If the organism is heterotrophic, it must eat or otherwise absorb food, like this alligator, or like a fungus. Alright. Another way we classify organisms is by how they reproduce. Asexual reproduction is with one parent. The cells or the organism just splits or divides. With sexual reproduction, you have to have two parents. Okay. There are 3 domains in classifying organisms. Alright, these are the biggest, widest groups. Those domains are bacteria, archaea, and eukarya. Alright? Bacteria are prokaryotic, and they cannot live in extreme environments. Archaea are also prokaryotes. They're very similar to bacteria, but many of them live in extreme environments. And then there's eukarya, which are any organism with eukaryotic cells. Alright? And then after our domains, we have kingdoms. And the kingdoms are in domain bacteria, there's just bacteria is the kingdom. In domain archaea, the kingdom is archaea, it's not divided up. But in domain eukarya, we have 4 kingdoms. Animalia are animals. Fungi are fungi. Plantae are plants. And protistas are single-celled organisms. And that's how we divide up our domains and kingdoms when we classify organisms. In Unit 12, we learned about ecosystems. Alright, and there's levels of organizations in ecosystems. Organism is a single living thing. Population are all the members of a particular type of organism in an area. A community is all the populations that live together in an area. And an ecosystem is all the living and non-living things that interact in an area. Okay. And we also learned about food pyramids showing energy flow. Okay. You have producers, primary consumers, secondary consumers, and tertiary consumers. At each level, the organisms in that level only get 10% of the energy that the ones below it had. So the producers take energy from the sun and then they're eaten by the primary consumers, and those are eaten by secondary, and those are eaten by tertiary consumers.